Bismillah ar-Rahman ar-Rahim. Let's look at this problem. OCW 21. 450 Newton load. So this one is 450 Newton load. Is suspended from a hook. So this is the hook. And it's supported by two cables, cable AC and cable AD. The K value for this spring is 5,000 Newton per meter. Cable AD lay, this cable AD, you can see that's very simple. You can see this cable has a rectangular shadow. This is in the negative Y and this is in the positive X. So cable AD only in the XY plane. That's it. There's nothing in the Z. And also the angle here is 30 degrees. And cable AC, you can see that the rectangular, this is in the negative X, and this is in the positive Z, which means that cable AC only lays on the XZ plane, nothing in the Y, nothing in the Y. So what we need to find, أول شيء, they need to find out unit vector AC. So unit vector AC, and that is what's needed. First of all, we need to find the coordinate of point A. Point A, let me just erase this. Unit vector here. I mean the coordinate of point A. This is at the origin, 0, 0, 0 meter. Let's look at point C. Point C, you can see that this one in the negative X, and that is 4 in the X, negative 4. And this one in the positive Z, so the Y is 0 and this is 3. So this is the coordinate of point C. Now we could find the unit vector easy. So the unit vector is equal to, as we mentioned in class, it is the position vector RAC over the magnitude of that position vector. So let's find this position vector. Minus 4 minus 0, it's minus 4i. Of course, j is 0, 0 minus 0. And 3 minus 0 plus, okay, plus 3k. Okay, this is in meters. You divide it by the position vector of magnitude of that position vector, 4 square plus 3 square. And that will give you 9 plus 16, that's 25, over square root of that is 5. So it is minus 4 over 5i plus 3 over 5k. And that is in, of course, there's no unit for this. This is the answer. You should put the answers like this. Minus 4 over 5, you put, let me see if I will put that for my solution. I'll put minus 0.8, 4 over 5, 4 over 5. I'll put minus 0.8 in the solution, minus 0.8. Of course, the I is there. And I'll put 3 over 5 plus 0.6. Okay. So I put this in the solution, and that's going to be correct. Okay, of course. And for the J, I'm going to put 0. There's nothing in the J. I'll put 0 on that so to show that the J is 0. Now, let's look at the second needed problem, the unit vector AD. Let's find the coordinate D. The coordinate D is very clearly, it is in the XY plane. So this one is cosine 30. Okay, so this one is in the negative Y, and this one here, it's sine 30. Of course, sine 30 is 0.5. That is in the positive X. And in the negative Y, let's see, what is cosine 30? So cosine 30, let's see, 30, let me just check it, my 30 cosine, so 30 cosine is 0.866, 30 sine is 0.5, and 30 cosine is, let me see, 30 cosine is 0.866. So this is in the negative y minus 0.866 minus 0.866, and xy, and in the z 0. So this is in meters. So we have it like that, and then this is the unit vector AD. Now the unit vector, you should do the position vector AD over the magnitude of that position vector, and this would be 0.5 minus 0, 0.5i, minus 0.86 minus 0 minus 0.866j, and then the k is 0 over. So now you have to square 0.5 plus 0.866 square, all under the square root. So 0.866 square plus 0.5 square, and the square root, this is 1. So that's going to give you 1. And this is 0.5i minus 0.866j. So what are you going to put into the solution? You're going to put a unit vector AD. The first one is 0.5i. Just put 0.5i. Let me just put it so I could also. 0.5i is correct. And you put the other one. You just want to do it 2 significant or 3 significant. That's good. 0.866j and 0k. So that's the answer for the second problem. Okay, let's look at what is needed next. They need the unit vector AB. What is the unit vector AB? Well, you could see here that the unit vector AB is only in the y, only in the j, nothing else. So the unit vector AB, it is at the j, at the y-axis. So the answer for that unit vector AB would be, there will be one possible solution for that. Let's say unit vector AB. Let me just put it there. It is j. Because of course, if you put it 1 square under square root, it will give you 1. So this is going to be the unit vector of the last one. So you put 0 for I, and you put 1 for j, and 0 for k, and that's it. Okay? Now, so we solved the first one, we solved the second one, and the third one. So what else needed? Now he need the tension AC, and he need the tension TAD, and he want the tension AB. So he want all these tensions, tension AC, AD, and AB. Okay? Okay, so now what to do? You have to sum up all the values. You have to just find out, once you find out the forces, and you just find out summation of forces at the x and summation of forces at the y, and to find out the forces, tension AC and tension AB and tension AD. So let's look at summation of forces at x equal to 0. This is, what's x? Oh, x is here, sorry. Okay, so what is the tension for the force? Let's see, FAD. FAD, cosine 30 in the negative y, and FAD, sine 30 in the positive x. So FAD. Let's just call it the same way that they want to make it tension or force, whatever. Tension AD. Let's say sine 30, and that is in the positive I. And then tension AD cosine 30 in the negative Y. Okay, so I want to sum up all the i's. Sorry, I want to do all the i's here because this is summation of force at the x. Sorry for the confusion. Summation force at the x. So I'm going to put only the i's. I'm going to ignore all the j's and all the k's. Only the i's here. Sorry. So I will do that. This is an I here. This one, A, B, there is no I, only in the J. And AC, there is one in the negative I. So tension AC. 4/5. Equal to 0. So this is the first equation. We have two unknowns and we have one equation. Let's do the second equation. Summation of forces at y equal to 0, and the direction of the positive is this way. This one, now we put this one, tension AD. Tension AD cosine 30, negative, minus tension cosine 30 in the J, minus tension AD in the negative J. And you can see that this one, tension AB in the positive Y, tension AB in the positive Y, and that's it. The other one only in the tension AC only in the XZ plane, and that is equal to 0. And summation of forces at Z equal to 0, Z is going up, positive. Tension AD, cable AD is not in the Z. Cable AB is not on the Z. Cable AC, cable AC, tension AC 3/5 plus tension AC 3/5. And this one, the 450, is in the negative Z, minus 450. Equal to 0. Nothing else in the Z. Nothing else on the Z. So there is equation 1, equation 2, equation 3. Let's look at equation 3. From this equation, you could make the elimination. 3/5 equal 450. What is tension AC? Tension AC is equal 450 times 5/3, and that is 750. Tension AC is 750, and what is the unit? Newton. So that is the first one. So this is, we find the tension AC. Let's come to this equation, equation 1. Equation 1. And let's put tension AD sine 30 equal tension AD. Tension AC 750, 4/5. So you could find tension AD. 750 times 4/5 divided by 30 sine. And that will give you 1,200. Make sure you put the unit. Tension AD is solved. Now the last one, tension AB. You come here and you put tension AB. So you go to equation 2. minus tension AD 1200 cosine 30 plus TB equal to 0, and then you could find TB 30 cosine, hold on, 30 cosine ضرب 1200. Okay, tension AB is 1039. Tension B, why I call it tension AB here, sorry. This is not tension B, this is tension AB. It's 1039. 1039 Newton. 1039 Newton. So we found tension AB, tension AD, and tension, let me put it in the, before the time. So tension, and that is okay. 1200 is okay, and 750 Newton is okay. The last requirement of this problem okay, let me just put it here. The last thing that you need from this problem is to find out, assume tension AB. So assuming, let me just put it here, assuming tension AB equal to 800 Newton. So which means, just take this. Okay, so this tension AB is 800 Newton. Neglect the value we did here. Neglect this one. Neglect this one. Tension AB here that we did in the previous slides. Okay, so tension AB is 800 Newton. Neglect the calculated value that we have. Determine the stretch of the spring. Remember the force of the spring? Force of the spring is equal K times S. He wants to find S. So S is equal the force of the spring over K. Now, the stretched, and that's what he needs at the end, stretched in the cable AB is equal. What is the force? He's assuming that the force of the cable AB is 800 Newton. So you put here 800 Newton. And what is K? K is this, given 5,000 Newton over meter. So 800 over 5,000, the answer is 0.16 meter. So the stretch of the spring is 0.16 meter. 0.16 meter, and that is a correct answer.